Good morning, welcome to Morning Maths, day 34 now. Get your pencil and paper or pen and paper and let's get going. So today the questions are all going to be mixed up again after year 3. So for year 4, 5 and 6, mixed up questions like we did yesterday. So mixture, not all in the same order that we've been used to. That's why I've got a mixture of flowers as the picture today. Year 3, we're going to stick with the normal order though. So question 1, year 3 level, how many tens is 700? How many tens is 700? Well, 700 is 700 units, but in tens it would be 70 tens. So 700 is 70 tens. That's question 1. Time for question 2. 234 added to 451. 234 added to 451. I didn't put the biggest number at the top, did I? But in plus, it doesn't matter. Added to means plus, of course. Let's check I copied it down correctly. Pause if you need time to copy. Actually, the good thing about today's question is no carrying was needed, because 4 plus 1 is 5. 3 plus 5 is 8 and 2 plus 4 is 6. So a nice easy one today. Plus made it get bigger. Plus makes things bigger usually. And question 3. 868 take away 264. 868 take away 264. Biggest number at the top in subtraction. I've got the biggest at the top. Okay, 8 take away 4 is 4. 6 take away 0, 0. 8 take away 2 is 6. Minus makes things smaller, so 868. We took something away and it got smaller. It was 604. It's the first number that gets smaller. Take something away from 868, you get a smaller number at the bottom, 604. Let's move on to question 4. 42 times 3. Okay, so this is the hardest question I'd say we've had so far in multiplication. You may know how to do it. There's lots of ways of doing this. Yesterday, I talked to you about what I call times tables in disguise, and I'll use that to help solve this question. So we've got 42 times 3. I'm going to split that up into 2 bits, because you know this 2 is worth units, 2 units. So I can do 2 times 3. And you know this 4 is worth tens, units and tens, 4 tens, so I can do 40 times 3. So what I can do for this question is I can do 2 times 3, because that takes care of this digit, and I'm also going to do 40 times 3. I'm going to do 2 questions in one, because 40 times 3, 40 is there, isn't it? 4t, 4 tens is 4t. So 2 times 3 goes here, and 4t times 3 goes here, and I'm going to get 2 answers for this question. So really I partitioned the 42, which means I split up or smashed up the 42 into 40 and 2. So 2 times 3 is 6. 40 times 3, I'm going to do this like I did yesterday. 40 times 3 is very much like 4 times 3. 4, 8, 12. 4 times 3 is 12. But it's not 4 times 3, it's 4t times 3. It had a 0 in the question, which I then place in the answer. Okay? So I did 2 times 3, which is 6, and I did 40 times 3, which was 120. So I have these 2 answers. 6 was the answer to 2 times 3, and 120 was the answer to 40 times 3. So I'll need to put them together at the end. When you put things together in maths, it's plus 6 plus 120, or 120 plus 6. That's quite an easy plus to do. 120, when you just plus 6 to it, it's just going to be 126. And the answer is 126. 42 times 3 is 126. Don't worry if you don't understand that the first time I've shown you it. You can just copy what I did. And we'll do it more every day, and in the end you'll get the hang of it. So that's one way, just one way you can do 42 times 3. I'll show you other ways in the future, but the answer is 126. Let's move on to question 5. So we're starting to do things a little bit differently here in times and divide at the moment. So I'm going to do 20 divided by 4 a bit differently to normal. 20 divided by 4. Hopefully you understand that 20 divided by 4 means 20 shared between 4. We've been doing lots of sharing in division. Also, you could say how many 4s in 20. That's another way of saying it. 20 divided by 4 is how many 4s fit into 20. So one way I've shown you before is you just sing your 4s until you get to 20. You sing this number until you get to this number. So you go 4, 8, 12, 16, 20. And if you do that on your fingers, 4, 8, 12, 16, 20, you get 5. Because 20 divided by 4 equals 5. Now you can also do a written version of that in the form of a number line. So if you get a number line, you start on 0 and you're going to go up to 20. You're going to see how many 4s, because 4 is there in the question, isn't it? How many 4s fit into 20? Because that's what division is. That's what dividing by 4 is. How many 4s fit into this number? And so you can do little jumps to go up in 4s. It's just like the songs really. 4, 8, 12, 16, 20. I didn't need quite all this space, did I? So I'm going to jump between them. 1 jump took us to 4. 2 jumps took us to 8. 3 jumps took us to 12. 4 jumps took us to 16. 5 jumps took us to 20. I didn't quite space this out correctly. You can see that's why there's a bigger gap here. But what's important is the number of jumps. 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps. Which means I could fit 4 into 25 times. That's why the answer was 5. So this really is just a picture of us singing our 4s up to 20. 4, 8, 12, 16, 20. And the numbers at the top are our fingers when we do the singing. 4, 8, 12, 16, 20. I end up, if I count on my fingers, with 5 fingers. So really this is a written version of singing the times table songs. You just see how many 4s are in 20 and the answer is 5. There's so many other ways of doing it, isn't there? I could get 20 of these little cubes, share them out into 4 groups, and there'd be 5 in each group. There's a lot of different ways of doing division, but as long as you get the idea that it's sharing, and this question, 20 divided by 4, is how many 4s fit into 20. That is division. How many somethings in a something is division. More about that in the future. Now we're going to the year 4 level work. Let's get rid of these flowers for the faster people. And question 6. 5,000 plus something is 5,775. I think I said that wrong. 5,005 plus a mystery. I feel like drawing the box today. Don't know why. Makes the line look a bit strange. Anyway, 5,005 plus something is 5,775. So what's missing? 5 doesn't need anything to get up to 5. 5 plus 0 is 5. 0 plus something is 7. Well, that's 7. 0 plus something is 7. 7. 5 plus something is 5. Nothing. So it was these 2 7s in the middle that were missing. What columns were they in? The tens column and the hundreds column were missing. So we can see what needs to go in the box. It's 0, 770. You don't need that 0, do you? So it's 770. That's what needs to go in the box. You could write this in lots of different ways. Maybe some of you can just see straight away. There's a 0 there, there's a 0 there. They get replaced by 7s. And that's the hundreds, tens columns. And the units column will need to be a 0. Hundreds, tens, units. 770. On to question 7. Reduce, what does that mean? It means minus. Reduce 1,000 by 683. So you take off the smaller number. Almost always you have the biggest number at the top in takeaway. 1,000 minus 683. So we're reducing 1,000 by 683. We'll need to do the borrowing or the taking, whatever you like to call it. It is really taking, isn't it? Because we don't give it back. but a lot of people will say borrowing. 10 take away 3 is 7. 9 take away 8, 1. 9 take away 6, 3. 0 could get written in, but doesn't need to be. So 317. And if you know number bonds to 1,000, you can look at these two numbers and think, well, their number bonds to 100, 83 and 17. Carried a 1, 6 and 3 and 1 is 10. That goes to 1,000. That's just a little check. You might not know what I mean in that check, but that's, some of you will. That's one way of checking. And we have our answer, 317, and we're on to question 8. 6 lots of 4,374. Multiplication, I'm going to put the biggest number at the top. It makes it a lot easier. A lot easier. We can use standard method. I'll do the grid method after this. 6 times 4, 24. I know some of you see if you can do these before me each time. 6 times 7, 42, plus 2, 44, which is great, as long as you're not rushing too much. 6 times 3, 18, plus 4, 22. 6 times 4, 24, plus 2, 26. That's a big answer, isn't it? 26,244. Right. I don't know if that's right. Don't think I've done anything wrong. I'll check it. I'll make it small, and I'll check it with the grid method. So, grid method, we have 4,000. We're going to partition this into 4,374. One good thing about the grid method is it gets you very good at your partitioning. Don't want to cross out what I did. You know very much how to split up 4,374 into its parts, which is an important skill in maths. Times by 6. Right, lots of times tables in disguise here. So 6 times 4 is 24. How many zeros to place in the question? 1, 2, 3. 1, 2, 3. 6 times 3 is 18. How many zeros to place? 1, 2. 1, 2. That's why I call it times tables in disguise, because that was 6 times 3 in disguise. 6 times 7 is 42. And 1 zero to place. And 6 times 4 is just 24. When the numbers get quite big, the addition gets quite big. You have to add up your 4 answers, which was this, 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 and this. Now, a common mistake is to line up the addition wrong when people have done the grid method. Make sure, I'm supposed to do a 0 in each square. That's okay. I'm trying to squeeze things a bit, which is not great, but I must make sure they line up in the right columns. Otherwise my addition will not go right. Okay. Once you've lined it up right, there's not normally that much carrying in these, and they're not too bad. So 4, 2 and 2 is another 4, isn't it? 8 and 4 is 12, 6 and 2. I'm never that confident when I do a multiplication question that's quite big, but I am confident if I see that that is the same as that, because I've done it in 2 different methods and got the same thing. So that's a nice check to have. Right, and we're on to question 9. Add, well, that's definitely going to be plus then. Add, that's an easy one. 2,389 and 875. Make sure you line it up down the right, it's down here. There's no decimals to worry about here. Just addition. Is that 12? 8 plus 1 is 9, yes 12. 3,264. It was 2,389. We added something, so it got bigger. 3,264. 9 plus 5 is 14, isn't it? Okay. Let's move on to question 10. Share. You must know what share means. It means divide. With a number this big, I'll use the bus stop, which I haven't shown the year 3s yet. But this is what we call the bus stop in year 4. How many 4s in 4? Well, exactly 1. How many 4s in 3? Well, 4 is too big to get into 3, so 0. But we must carry the 3 that we didn't use. How many 4s in 32? I will sing my 4s till I get to 32. 4, 8, 12, 16, 20, 24, and 28, and 32. My finger said 8. How many 4s in 0? 0. It's important to know that share 4,320 between 4 means how many 4s fit into this. How many somethings in a something? That is division. How many 4s fit into 4,320? The answer was 1,080. And let's move on to the year 5 level work. Number 11, how many 10s is 90,000? Well, that's a lot of 10s. 90,000. It's 90,000s, isn't it? Because it's called 90,000. So it must be 90,000s. But they're asking for how many 10s it is. It's 90,000 units as well. Well, it's 90,000 units. 90,000 units. It's 9,000 10s, which is our answer. It's 900 hundreds. It's 90,000, because it's called 90,000 anyway. And it's 9 10,000s. But the one that we wanted was the 10s. And it is 9,000 10s. 9,000 10s. I hope these questions are giving you a better understanding of a more unusual aspect of place value, which you will be asked. So 90,000 is worth 9,000 10s. And we're on question 12. What's this? More than. What sign is more than? More than is plus. More is plus. More than is plus. But watch out for how many more. Or how much more. Because they're trick questions. They're actually minus. So more than, though, is plus. More is usually plus. But just watch out for the how many or how much more. 6.56 more than 3.74. So this one is plus. 6 plus 4 is 10. 5 plus 7, 12, plus 1, 13. 6 plus 3, 9, plus 1, 10. 10.30. Ends in a 0 because 6 plus 4 is numbered onto 10. That's why it ends in a 0. 6 and a bit plus 3 and a bit was 10 and a bit. Maybe it should be 9 and a bit, because 6 plus 3 is 9, but the carried one is what made it go to 10. So it is 10.30. 10.30, also known as 10.3, of course. And we're on question, that was question 12, sorry I didn't write the number, and we're on question 13. Decrease, do you know what decrease means? Decrease is going down, decrease down, so it's take away. Decrease 10 by 4.67. Decrease 10, I'm going to make it 10.00, so I can line up a point. If one of the numbers has a point and the other doesn't, I'll put a decimal point on both. And if a number like 10 doesn't have a decimal point, where does it go? At the end. 10.00 to line up with 4.67. Lots of borrowing or taking here. We've got to go all the way across. Just be careful. When you get this last 10, don't cross it out and make it a 9. It stays as 10. 10 take away 7 is 3, 9 take away 6 is 3, 9 take away 4 is 5, and 0 at the front. 5.33. Number bond check on this, because 33 and 67 makes 100. Yeah, 10 take away 4 and a bit was 5 and a bit. That looks okay. Minus makes things smaller usually. And we're on question 14. How many 6s in 5,274? I've been talking about this with year 3 and year 4 today. How many somethings in a something is division? How many somethings in a something is division? How many 6s in 5,274 is division? And when it's a number as big as 5,274, you're going to really need to use the bus stop, because we could take off 6 lots and lots of times and we'd get an answer, but it would just take so much writing, so much work. We could sing our 6s up to 5,274, but we don't know our 6s up that high. This is why we use the bus stop for numbers like this. How many 6s in 5? None, because 6 is too big to fit into 5. There's lots of 6s in 52, so I'll sing my 6 times table, but I mustn't go past 52. 6 and 12, 18 and 24, then 30, 36 and 42. 48. That's all I'm going to be able to do, up to 48. I've got 8 fingers here, because 6 fitted into 48 8 times. So I put the 8 at the front, which my fingers showed me. but I only sang up to 48, if you'll remember, and that says 52. So I count in ones from my 48 up to 52. 49, 50, 51, 52, and it was remainder 4. This is quite a difficult one, this one. How many sixes in 47? So I sing my sixes, but I mustn't go past 47. 6 and 12. What am I doing? 6, start again. 6 and 12, 18 and 24. Then 30, 36 and 42. That's all I can do. 7 fingers I had. 7 sixes was 42, but this is 47. So I count in ones up from 42 to 47. Don't count 42. Start counting after 42 and go up to 47. So counting in ones, 43, 44, 45, 46, 47. I have a remainder of 5. Now hopefully 6 fits into 54. Wonder if you know. Let's count our sixes, don't go past 54. Hopefully go exactly to 54. 6 and 12, 18 and 24. Then 30, 36 and 42. 48 and 54. I've got 9 fingers. I sang to exactly 54, which means there's no remainder, which is very nice at the end. And our answer is 879. And time for question 15. Question 15 says product. Famous word in maths. Product. Product of 12 and 0.3. Well, product means times. So we're multiplying 12 by 0.3. With multiplication, you don't line up the point correctly. So I line it up like this. I'll put the point in at the end. There it goes. So just get that copied down. You might want to place this 0 here. Just give me a second. We've got a few people in school these days. And it's break time, so I just had to shut the window to keep it quiet for you. So 12 times 0.3. Right, 3 times 2 is 6. 3 times 1 is 3. 0 times 2 is 0. 0 times 1 is 0. So what is it, 36? Well, it's not 36 because we had 1 decimal place in the question, so we need 1 in the answer. It's 3.6. This one you could possibly have done with times tables in disguise. Have a look at this. 12 times 0.3. It's a lot like 12 times 3. Very similar to 12 times 3. 12 times 3 is 36, but it had 1 decimal place in the question, so you put it in there and you get 3.6. So we could have done that one with times tables in disguise, or more exact decimal times tables in disguise. Either way though, our answer is 3.6, and hopefully you know now, if you didn't know before, that product means times. And we're on year 6's questions. This is a place value question really, as I said yesterday. I'm going to use what I call a moving method to do this. And you can use a moving method, which is an easy method. Well, you don't have to write much, but I notice a lot of people lack accuracy on this method and take a long time to get accurate on this. But when you're divided by 10 or 100 or 1,000, in this case we're dividing by 100, you don't need to do much. I just note down that I'm dividing by 1,000. You don't need to do much to this number. I put a decimal point on the end of it, line one up underneath, and I'm going to make it smaller because division makes things smaller usually. Smaller stuff goes this way towards the decimal end of numbers, doesn't it? Doesn't go this way because that's where the big stuff is. It goes towards the small end. So I'm going to move it smaller. When you divide by 100, because there's 2 zeros, 1, 2, you move it 2 places smaller. So the 3, instead of going in the same place value, instead of going in this thousands column where it is now, it goes 1, 2 places smaller. If I did put the hats on, units, tens, hundreds and thousands, squeeze thousands in, it's gone from the thousands to the tens. That's definitely getting smaller, isn't it? If something's gone from thousands into just tens. The 6, instead of being in the same column, the hundreds column, it goes 1, 2 places smaller. Now it's only in the units column. It's got smaller, but that's right, because division makes things smaller. 5 tens. The 5, instead of going underneath where there's no room anyway, it goes 1, 2 places smaller over here. And the 4, instead of going underneath, there's no room anyway, it goes 1, 2 places smaller. Can you see that 3, 6, 5, 4 still goes 3, 6, 5, 4? The digits are still in the same order that they were before. They've just all shifted across. They've all shifted across to the right, which is over here, the right. because when you move things to the right, you're moving them towards the small end. You're making them smaller. So that's the moving method. Most of that you don't have to write. You could literally just write that. You don't even need this. You could literally just write that for this question. Divided by 100, you move it 2 places smaller. Some people like to do this in their head. I find that only about 10 or 20% of people get these right every time when they do them in their head. So just be very careful on these. This is the one thing in maths that I find year 6s take a long time to get accurate with. It's not the hardest thing in the world, but at accuracy, people will make little mistakes on these, so be careful. And we're on number 17. Double 99.9. Double 99.9. Double means times 2. 99.9 times 2. I write it out incorrectly first, which is what happens when you're multiplying with times and decimals, and I pop the point in at the end. So this is not lined up correctly as if it was plus or minus or divide. With times, you just have to line it up without lining it up correctly, if you know what I mean. And this is what you have to do. 99.9 times 2. So 2 times 9, 18. 2 times 9, 18 plus 1, 19. 2 times 9, 18 plus 1, 19. 1,998. Does that sound right? 99 and a bit times 2 is 1,998. Definitely not, because there's a decimal place there, which is a number after a decimal point, so there needs to be a decimal place in the answer as well. 199.8. Double 100 would be 200. Double 99.9 is very nearly 200. It's 199 and a bit, 199.8. And question 18. Take something away from 9. Take 2 and a bit away from 9. That's definitely take away. What number goes at the top? 9, because that's bigger, and that's what's getting something taken away from it. As you know, 9 is the same as 9.00. If one number has a decimal and the other doesn't, I put a decimal on the other and place the same number of decimal places. So we can do 9 point nothing, take away 2.47. I'm sure you know that 9.00 is the same as 9. You need to know that if you didn't. Let's do our taking away. Lots of borrowing or taking. 10 take away 7, 3. 9 take away 4, 5. 8 take away 2, 6. 6.53. 9 take away 2 and a bit is 6 and a bit. There's a number bond check, because those number bonds make 100, don't they? 47 and 53. 6.53, and we're on question 19. Similar to what we've been doing the last few days. How do you find a fifth of 8,000? Well, finding a fifth is dividing by 5. That's how you find a fifth of something, you divide it by 5. This should be a nice easy bus stop, this one. But it's knowing what to do. Knowing that find a fifth means just divide by 5. How many 5s in 8? 1, remainder 3. How many 5s in 30? 5, 10, 15, 20, 25, 30. That is 6. How many 5s in 0? That is 0. And how many 5s in 0? That's also 0. 1,600. So a fifth of 8,000 is 1,600. Let's go to question 20. I just wanted to see if I could trick any of you with this. I don't know if I have. Add 0 to 600. The answer is going to be 600, because it's 600 plus 0, which is obviously just 600. I was just trying to trick a few of you to see if you would write. You would just literally add a 0 on the end and say that it was 6,000 by putting the 0 on the end. Did anyone do that? Hopefully not, because add 0 to 600 means it is 600. If I tricked you, try not to let that happen next time. Time for the answers. Pause if you need to check your work, if you did it all on your own. If you're doing it on your own and you're not getting them all right, or you're getting quite a few wrong, then it's probably better that you work with the teacher until you're more confident. Because really, we are all aiming for like complete accuracy on this. 100% accuracy is the aim. And if you can be 100% accurate, then try and get really fast as well. Anyway, I'll see you next time. Thanks for listening.